All right, so recording has started. So as I said, probability lecture 1, 2, 3, right? So I will give one question from here. And then we have probability lecture 4. So I'll give one small question from there as well. So, and then of course, binomial and multinomial. This was one lecture, one question. Poisson distribution, one question, and normal distribution, one question. So in this one, probability lecture 1, simple probability questions, maybe short questions like that, simple probability questions. In like the sample space, for example, if you toss a coin, what is the probability of tossing? What is the probability of head in tossing one coin? Or what is the probability of 5 if I roll a die? What is the probability of a king if I draw a card from 52 playing cards? Like that. Simple questions. Okay. Short questions. So lecture 1, 2, 3. Probability lecture 1, 2, 3. Simple probability questions from here. Okay. So the question that you were asking was from 4, which is actually the Bayes law, right? Bayes law or Bayes rule. Sometimes they call it Bayes theorem. Uh, Here, important thing is that first of all, you will be given a partition of a sample space. Means any scenario will be given, and you will have a partitioning of that. Means A1, A2, A3, or B1, B2, B3, whatever. So if you take the union, it gives you the whole sample space. And if you take the intersection of any two, it is empty. A1 with A2, A1 with A3, A2 with A3. If you pick any two of them, their intersection will be empty. So if these conditions are satisfied, we call them a partition, right? So A1, A2, A3 is called a partition of S. So basically, they are mutually exclusive because they have nothing in common. Mutually exclusive means nothing in common. And they are exhaustive events. Exhaustive means they give you the whole sample space. If you combine them, they give you the whole sample space. So this is the property. So if you read the question, you will see that there will be some events who cover everything. So they are your given events A1, A2, A3. So first thing is that probability of A1, probability of A2, probability of A3, that will be given. Okay, so these probabilities will be given. Okay, and if you add them, if you take the sum of these probabilities, it will give you 1. You can check that. Then they will define another event here, any general event B, right? So this B is not a part of a partition. So then they will give you some general event B, define B, right? And they will give you the probability of B if one of AIs is given to you. Means they will not give you the probability of B. They will give you probability B given A1, B given A2, B given A3. So these conditional probabilities will be given to you. Okay, so these things will be given. One thing is probability of A1, A2, A3, and probability of B1 given A1, B given A2, B given A3. These will be given. Charging is going down. So Okay. Then they will ask you opposite to this one. Means what is the so question is here is what is the probability of B? They can ask you this without A1, A2, A3, right? Or they can also ask you what is the probability of A given B. Any one of them, A1 given B or A2 given B or A3 given B. If these are the questions, this comes from the law of total probability, and this comes from the Bayes law. So these two questions will be given to you. Okay, so even if they don't ask you this, even if they only ask you this one, if they only ask, okay, use Bayes rule to find the probability of A1 given B. So what you will do, you will swap them. This is the Bayes rule. I will write this Bayes rule in the exam. Okay, so you don't have to worry about that. So probability of, so you what you do, you swap them. You see, you change their position. A1 given B becomes B given A1. But if you do that, you multiply this A1 here. Okay, and then you divide by the probability of B. This probability, this given probability B goes down. And this probability comes from the law of total probability. You see, even if they don't ask you probability of B, you need it in the Bayes law. So this probability of B comes from the law of total probability, basically, right? So that is you, because the given is this, you don't know what is probability of B, but you know probability of B given A1. This is what you know. You know probability of B given A2. You know probability of B given A3. These three things are given. So what we do, we replace B by B given A1, but then I will multiply by A1. And plus, you will do B given A2 into A2 plus B given A3 into A3. So if you add all these, this is called the law of total probability. So you will calculate this one and put it here. All right. So now you see on the right hand side, everything is given to me. I can use Bayes law to answer the question. So for example, if I open the assignment, I think it was in assignment 3 or 2, I don't know. Yeah, this is the assignment from Bayes rule. You see here, right? So see, in a certain assembly plant, three machines, B1, B2, B3 make 30, 45, and 25% respectively of the products. So it means in a plant, in a company, in a factory where different products are being manufactured, only three machines are working. So it means this is the whole thing. B1, B2, B3 is the whole thing here, right? Can I write here? Let me open this in Edge. With Edge. Now I can write this one. So see here, if you look at that, so because here you see whatever your sample space is, it's a factory, it's a company, right? So B1 makes some products, B2 makes some products, and B3 makes some products. It means B1, B2, B3 give me a partition. A product that is made on B1, it will not be made on B2 and B3. So it means their intersection is empty, right? And if you take the union, it gives you the complete sample space because there is no product which is manufactured by any other machine. Only three machines are there. And if you look at this one, what is the probability that a product is made on machine B1? It's 30%, because now you see these are probability that a product is manufactured on B1. So 30% chance. So it is 0.30. It is made on B2, 45% chance, 0.45. And what is the probability that it is made on B3? So a 25% chance, so 0.23. So now if you add them, you see 0.3 plus 0.45 plus 0.25 is equal to 1. So we should check it whether the sum of all these probabilities is 1 or not. So if you add them, it's clearly 1. So this is one check which we have done. Now look for the event. Look for this event B, whatever that is. Now I will not call it B. So let's see what they say. It is known from past experience that 2%, 3%, 2% of the products made by each machine respectively are defective. So it means now my event is defective. This is something which is defined on all this, because all the machines are producing some defective items as well. So 2% from machine 1, 3% from machine 2, and 2% from machine 3 are defective. So I can call D for defective. I can say that let D be the defective product. Okay, defective product made by any machine. I don't know. D is the, so I can call this D. This one is D. Okay. So now what are these probabilities? These are the conditional probabilities. If you look at them, these are the probability of defective given that it was produced on machine 1 is 2%, 0.02. It is not just the probability of D, not just the defective. Defective on machine 1, 3% is defective on machine 2, and defective on machine 3. So 3% is defective on machine 2 and 2% defective on machine 3. So you see, as I told you, that whenever this thing is given, whenever this scenario is given, they will give you the probabilities of the partition, which in our case is B1, B2, B3. So they are given. And if you define another event, then B given A1, B given A2, B given A3, they will also be given to you. See these probabilities. So in my question here, D was the event that is defined on a sample space. So D given B1, D given B2, D given B3, they should be given. So see, I have the probabilities. Now you ask me anything, I will answer. So here in A part, they said, what is the probability of defective? That's it. It is defective. Probability of D without given. So I can use law of total probability. What is the probability that it is made by machine 3 given that it is defective? So they are asking me what is the probability of B3 given that it is defective. So you see here, what is given to me? D given B3. But they ask me the opposite, B3 given D. So this is Bayes rule. So see, one comes from the law of total probability, one comes from the Bayes rule. So if I go back here, it was assignment 3, question 1, right? So B1, B2, B3 was given, and this is D, right? Because defective is made by all the machines. So it has intersection with everyone. So they gave me probability of B1, probability of B2, probability of B3. These were given to me. 30%, 45%, and 25%, right? And then they give me probability of D given B1, which is 0.02, probability of D given B2, defective on machine 2, and defective on machine 3, 0.02, right? So now in A part, they ask me what is the probability of a defective. So what we do, we start with defective with B1 into B1 plus defective with B2 into B2. So see, I will write this formula in the exam, but see, writing this formula is so easy. If you have the concept, it is so easy. Now I have all these values. This is 0.02, B1 is 0.3. This is 0.03, B2 is 0.45. D given B3 is 0.02 and B3 is 0.25, right? So you can get this answer here. In the second part, they ask me what is the probability of B3 given D? Opposite. So what we do, we change it. We go back to our original position, D given B3. But when I do that, I multiply by B3. But in the denominator, I just have probability of D, right? So that I have already calculated here. So I will put it here. So this will become D3 is 0.02 and probability of B3 is 0.25, and of course D whatever I got from here. Okay, so very easy. If you understand the question, it's nothing. All right, so you have to be careful because of course I will give you a second problem from this lecture, so you can keep that in mind as well, that this question has to be from Bayes rule, so we can adopt the appropriate formula. Is that clear, Mohammed?
Yeah.
Any questions? Anyone else? If you have any questions. So see, this question is with uh, three events um, in your partition. It may have only two events, maybe, right? If it has just B1, B2, and then you are defining an event D here, right? Or any other event, then you see probability will change. Then it will be D given B1 into B1 plus D given B2 into B2, and then that's it. There is no B3. So I will stop here. I will not have this third term, right? And if there are four, let's say B1, B2, B3, B4, B3, B4, then of course I will have with B3 and then I will have with B4 as well. So it depends how many events are there in your partition. So they will give you those total number of terms. Okay. So if there are only two events, I will stop at two. If there are three events, I will stop at three here. And if there are four events, I will stop at four and so on. But of course, I will not give you many, just two or three at the most. I think this second problem only has two. You see, a paint store chain produces and sells latex and semi-gloss paints. See, only two categories of paints. So here, your sample space only has two events. One is the latex and one is the semi-gloss. I can call them all and S, right? Uh, and Of those that purchase latex paints, 60% also purchase rollers. Rollers are the brushes with which you paint the walls, right? So of course, if you are buying paint, you may be buying a roller as well. So you can call R as roller because a latex paint buyer can purchase roller. A semi-gloss paint buyer can also purchase roller. So R is the one which is defined on both of them. So now they can ask you what is the probability of roller, or what is the probability of L given roller, S given roller, anything can be asked. They can ask you probability of R. They can ask you probability of L given R, S given R. Anything can be asked. So here they ask you uh, purchases a roller and a can. What is the probability that the paint is latex, right? So see, they said what is the probability that the paint is latex L given that he purchased a roller. You see, a selected buyer purchases roller and a can of paint. So he said roller they have already purchased, but what is the probability that the can which they bought is latex? So see this one, the second one. So for that, I will need probability of R given L into L divided by probability of R. So you will find this R from the total probability, and then you will answer only L given R from the Bayes rule. So I hope it helps. If I open the other one, then we have three. Let me open it in Edge so that I can write on it. All right. So see here, I gave you some binomial distribution problems, multinomial distribution problems, Poisson distribution problems, and then normal distribution problems, right? So this will give you the next three topics. So let me first briefly say something about binomial distribution. In binomial distribution, you have to find, they will say that let X or any random variable that they are defining, they will give you the probability of success. They'll give you the probability of something. Probability of success. Success is basically something which they ask in a question. So whatever they ask in a question, that is our success. In simple words, it may be failure, but what I have to answer, that is my success. And then they give you n, which is the number of trials, right? Number of trials. So if these two things are given, then we say that X, a random variable X, has a binomial distribution with parameters n and p, right? Then we can write probability of random variable X takes the value small x as ncx p to the power x 1 minus p to the power n minus x. And now your X can be 0 success, 1 success, 2 successes, or all successes, because n is the total number of trials. So you can have all successes as well. So for example, if I pick something from here, let's see this one. In testing a certain kind of truck tire, right? They are testing a tire. It is found that 25% of the trucks fail to complete the test without a blowout. Means they fail the test. It means their tire blows out, right? It gets punctured. So they cannot pass it. So this is the test for failure, right? Fail to complete the test run without a blowout. Now it is not my success. Now you see, this is the property, but I have to wait. Let's see what they are asking me. Is it P? I don't know. Probability of success. Of the next 15 trucks tested, so it means this is my N, total number of trials, total number of tests that I made. So this is my N. N is 15. So this is given. Find the probability that 3 to 6 have blowouts. It means it is the same thing. 25% of the trucks failed to complete the test without a blowout, right? It means 25% of the trucks had the blowout. Agree? They did not complete the test. It means they had a blowout. So it means this is the probability P. P is the probability of success. But I will first define. So let's say assignment 4, question number 3. We will first define at X. Let X be the number of blowouts, right? If you look at that, find the probability that have blowouts. 3 to 6 trucks have blowouts. So I can say that number of trucks having blowouts, right? Because whatever the question is, I have to consider that as X. Then X is a binomial random variable with n and p, where n is 15 and p is 25%. Probability of a blowout in one test. See, what is p? Probability of having same thing. You see, having blowout, having blowout. So probability of having blowout in one test. Okay, in one test. In just one trial, what is the probability of having a blowout? That is my P. And N is the total number of trials. Here, the total number of trials are total number of tests. All right. So therefore, when it follows the binomial distribution, then I can write n is 15, cx, and p, which is 0.25 to the power x, and 1 minus p. 1 minus p will be 0.75 to the 15 minus x. So that is my binomial formula. Now ask me any question. So step 1 is define random variable. Step 2 is see what distribution it has. It may have a Poisson distribution, right? Not binomial. So we will write that. And then step 3 is once you know what distribution it has, then write down the formula. If it is binomial, write down the. Now step 4 is answer questions, whatever they are asking. Now answer the question, what they are asking. Okay. So what were the questions? Question is, what is the probability that you have from 3 to 6 blowouts? So they are asking you the probability of X from 3 to 6 blowouts. So it means either X has 3 blowouts or 4 blowouts or 5 blowouts or 6 blowouts. When we have or, we add them because it's a discrete distribution. So in discrete distribution, we add them. Okay. We add 3, 4, 5, 6. Someone is coming. So now what will be x equal to 3? I have to put x equal to 3, right? So see here, whatever x is here, x, it goes here, x, 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 right? So now if x is 3, right, I will put 3 for red one, then 5, then 6. So this is what you have to write. So 15C3. 0.25 to the power 3, 0.75 to the power 15 minus 3, which is 12. Now it is 4, so P has 4 and other one will have 11 because the sum of the powers should always remain 15 because n is 15. So the sum of the power is always n. 3, 12, 4, 11, 5, 10. 15C5. Now for the 5, I will have 5 here. Now P has 5, so 1 minus P will have 10. Then 15C6. 0.25 has 6, so 0.75 will have 9. So now you can use calculator and write all the answers. 1, 2, 3, 4, and it will give you an answer. So binomial distribution is easy, but you have to see what is happening. Your random variable has only 2 outcomes, success or failure. So see in this question, if you do the test for the tire, either the tire will complete the test without blowing out or it will blow out during the test. There is no third possibility. So see, this test run has only 2 outcomes. All right. So it is a binomial distribution. So now look for n and p. Once you got n and p, you can write down the formula for the binomial. And now whatever they are asking, you get the answer from the formula. If it is exactly something like fewer than 4, fewer means less. Okay. Fewer than less. So here they are asking you probability of x less than 4. So it means 0, 1, 2, 3. Then more than 5. More than 5 means x greater than 5. So 6, 7, 8, 9, 10, 11. Okay. For let me give another thing. Let's say if they are asking you probability of x greater than 5, more than 5. So you see, if you start, you have to go up to 15, you see, right? Starting from 0. So 5 is here. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So too many probabilities. 6, 7, 8, 9, 10, 11, 13, 14, 15. So 9 probabilities here. 9 of them. But if you go to the opposite sides, you have from 0 to 5, 1, 2, 3, 4, 5. So there are 6 probabilities. 0, 1, 2, 3, 4, 5. So 6 probabilities. So it's your choice if you want to go to the shorter part or the higher part. So if you go it directly, it will give you 9 probabilities. But if you go to the opposite side, you have to find this. But instead of that, you found this one. We know that the total probability is 1. So you can subtract this from 1 to get this probability on the right hand side. So if you go to the opposite side, see, greater becomes less than or equal. And now you can subtract from 1. It will exactly give you the same thing. Okay, so here you can reduce your work because less than or equal to 5 only have 0, 1, 2, 3, 4, 5, 6 probabilities. But if you go directly, it has 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right, see, too many here. So it's better to go to the other side and do that. You see, in the B part, they said probability of x less than 4, fewer than 4. So here I know that fewer than 4 is just 0, 1, 2, 3. So we can do it directly because there are only 4 probabilities. 4 is not included. 4 is not included. So 0, 1, 2, 3 only. But on the other side, if I do that greater than equal to 4, this is the same as this. But now from 4 onward, I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 10 probabilities. So I will not do that. I will do it directly because there are only 4 probabilities if I go direct route. Okay. So it's your choice. You want to go to the other side and subtract from 1, or you want to directly compute. Sometimes direct computation gives you less computation and opposite gives you more. Sometimes opposite give you less computation than direct one. So it's our choice how we can do that. In multinomial distribution, you see binomial is 2, multinomial is more, right? More than 2. So here your outcomes will be more than 2, right? Bi is used for only 2. That's why we call them 2, right? So bi means only 2 outcomes. That's why we have the name binomial distribution. So multinomial means more than 2 outcomes, right? More than 2 outcomes. So here I cannot use binomial formula. So this is also easy. If one outcome gives you probability P1, second outcome gives you P2, third outcome P3, and so on, right? Then of course you have n is the total number of trials. So you will be given n and P1, P2, P3, P4, P5, P6, whatever in the question is. So here you see the probabilities are 0 0.4, 0 0.2, 0 0.3, 0 0.1 respectively that a delegate, a people who arrive by air, by bus, by automobile, by train. So they see 4 different outcomes. Some delegation, some group of people are coming to a convention, right? And there are 4 possibilities that they can come by air, they can come by bus, they can come by car and or by train. So see, there are 4 outcomes here. It's not a binomial. So it means these are the probabilities P1, P2, P3, P4. So I will first define, I will say that let X1 be the number of delegations, X1 are the number of delegates arriving by air. The first one was by air. So I will give them the variables. X2, the number of delegates arriving by bus, the second one. The third one, number of delegates that arrive by car or automobile. Automobile is a car, right? And X4 are the number of delegates that come by train. So then if this is the case, then what is the probability of X1? Probability of coming by car, it's zero point 0.4. Sorry, by air. Probability of coming by bus is 0.2. Probability of coming by car, automobile, 0.3. By train is 0.1. So these are the probabilities. So what is N now? He said, what is the probability that among 9 delegates randomly selected at the convention? So it means my N is 9. I am considering 9 delegates. So N is 9. So see, N is given and P1, P2, P3 is given. So what is the property? They say, what is the property that 3 arrive by air, 3 arrive by bus, 1 arrive by automobile, and 2 arrive by train. So these are my X1, the value of the variable, X2, X3, and X4. So when this is the case, we write this probability of X1, X2, X3, X4, and then we write P1, P2, P3, P4, and then we write N. This is your multinomial distribution. And what is the formula? N factorial over X1 factorial, X2 factorial, X3 factorial, X4 factorial, P1 to the power X1, P2 to the power X1, P3 to the power X1, P4 to the power X1. So we just need to put the value. So what is X1? 3, 3, 1, 2. So X1, 3, X2, 3, X3, 1, X4, 2. Then what is P1? P1 is 0.4, P2 is 0.2, 0.3, 0.1, and then N is 9 number of delegations. So now I can replace the values. 9 factorial divided by X1 factorial, X2 factorial, X3 factorial, X4 factorial. P1 to the power X1, P2 to the power X2, P3 is 0.3 to the power X3, and P4 to the power 2. Right? So see, 0.4 to the power 3, 0.32 to the power 3, 0.3 to the power 1, and 0.1 to the power 2. Right? So that's how we can just write the formula and write the answer. So in multinomial, you will have more than 2 outcomes. Call them x1, x2, x3, x4, whatever. If 3 are given, x1, x2, x3, and then look for the probabilities of x1, x2, x3. Call them p1, p2, p3. Then n will be given. Just put this in the formula. You'll get the answer. In Poisson distribution, you have 2 things. Poisson distribution has only one parameter, which is called lambda. Okay, lambda is the only parameter, and usually it is the average, because Poisson distribution is gives you the frequency of something, means how often some event is occurring. Okay, let's say during certain amount of time, in one day, in 1 hour, or whatever, how many times something is occurring. So lambda is the average number of times an event occurs. Average number of times an event occur. So we can say that, let's say, let on average only 10 days in a year there is rain in Buremi, let's say. On average, in 1 year, 10 days, we have the rain. So this lambda will become 10 because it gives you the average number of times some event is happening. Rain is occurring 10 times in 1 year, right? Or some other thing. Accidents, maybe accidents happen every day, right? So we can say that on average, there are 3 accidents per day in Oman, let's say, right? So on average, there are 3 accidents per day in Oman. So it's a frequency, right? So lambda will be 3, 3 accidents per day because it's the average in certain amount of time in 1 day. Okay, if that is given, then you can say that probability that in the next day there will be no accident, they can ask you. So probability of x equal to 0. Or you can say that in next day there are more than 3 accidents. 3 was the average, but let's say more than 3 accidents. So if they ask you this question, it follows Poisson distribution, whose formula is this: lambda x by x factorial. And here x goes from 0, 1, 2, and there is no n. So it keeps on going till infinity. There may be 100 accidents per day. So we cannot put a limit on that. All right. That's a Poisson distribution. So sometimes they don't give you this scenario. They give you a binomial scenario. For example, they give you binomial question where n is very large. N is greater than or equal to 100, very large. If n is very large, but if you multiply n with p, because when x is a binomial distribution, it has n and p, right? N and p are given. So p is small, n very large, but p small, such that your NP becomes less than or equal to 10. Then we can use Poisson distribution instead of binomial. Question was binomial distribution. Question was binomial, see, right? But we are using Poisson, but for Poisson distribution, we need lambda, not NP. Because lambda is the average of Poisson distribution, we know that the mean of the binomial distribution is NP. So because lambda is the mean of Poisson distribution, NP is the mean of binomial distribution, so we equate them. We take lambda as NP. So my formula will become e to the power minus NP, NP to the power x by x factorial. So see, it was a question from probability, but we used Poisson to answer that. For example, here you see the probability that a person will die when she contracts a virus infection is 0.001, right? Of the next 4,000 people infected, what is the mean number who will die? So n is 400. People who get virus infection is p, because we are interested in people who die. So the probability of dying is 0.001, that's p. So see, n is very large, 4,000. P is very small, 0.001. This was a binomial question, but we can answer using Poisson. So if I multiply n with p, I think it will become 4. So see, it is less than or equal to 10. So we are good. So it means we can use Poisson. N is greater than 100, of course. So we can use Poisson. So there they ask what is the mean number of people who die. So of course, mean number is mu, which is NP. that is 4. So answer is right there. But usually they don't ask us this. Usually they ask us the probability. So if they ask us the probability, it is e to the power minus np, np to the power x by x factorial. See, np was 4. So I put 4 here, right? So now if they ask you what is the probability that only 10 people die from that virus, you will put 10 by 10 factorial. Get the answer, right? This is your x. So you'll put it for x. If they ask you what is the probability that less than 3 people die, right? So it means 0, 1, 2. I noticed that some students leave this 0. When they are answering the question less than 3, they just write 1, 2. 0 is also the possibility. X starts from 0. No person dies, right, from that virus. So 0 is also there. So always start from 0. And then, of course, you can write that e to the power minus 4, 4 to the power 0 by 0 factorial, minus 4, 4, 1 by 1 factorial, minus 4, 4, 2 by 2. E to the power minus 4 is common. You can write outside 4 power 0 by 0 factorial is 1 plus 4 1 by 1 factorial is 4 and 4 square by 2. So you can answer this question. So calculating Poisson probabilities are easier than calculating binomial probabilities, especially when n is very, very large. Binomial probabilities are not very easy to calculate. So this is another reason we go for the Poisson distribution. And this Poisson distribution gives you a very good answers because it is an approximation. It gives you very good answers when n is very, very large. So we see n is 4,000, which is definitely very large, and p is small. So this will give you a good answer. After that, we had normal distribution. Normal distribution is a continuous random distribution, right? It's not discrete. So here we know that when we have a continuous random variable x, right, then the probability of x is equal to some number we cannot calculate. It's always 0. Okay, and we can only give the probabilities of intervals. And intervals probability is probability from a to b fx dx, where fx is the probability density function. Fx is probability density function. But in normal distribution, your fx is something which is not integrable. We cannot use this one. So instead of that, we use tables to answer the questions here. Use table, a standard normal table. And of course, this table will be given to you in the paper. Of course, without this table, you cannot answer. You cannot memorize this table. So standard normal table is given. In standard normal table, when x is a normal distribution with mean mu and various sigma square, so that are the parameters. Mu and sigma are parameters of normal distribution. Binomial had parameter n and p. Poisson had parameter only lambda. And normal has a parameter mu and sigma, where mu is the mean, right? And sigma is the standard deviation. So these will be given, of course, in the question. So if this is the case, then what is the first step? This is, if this is given, then step 1 is that write write z. Right away, write down z. Z is x minus mu by sigma. This is called standard normal variable. Z is called standard normal variable. X is a normal variable. Z is a standard normal variable. Standard. Okay. And tables of Z are basically given. That's why we convert this to Z. So tables are given where this is written up to 1 decimal place, I think minus 3.4 to they start, and they go to plus 3.4, and 0.00, 0.01, 0.02 up to 0.09 is given. So if you want to find, so this gives you the probability to the left. This is your normal curve. Right in between it's 0 if you are looking at Z curve. So let's say if this is 1.23, right? So if you look at 1.2 here, you will look at 1.2 here and 0.03 here. So this probability, right? This is the area to the left of Z. This is the area to the left of Z. Area under the normal curve to the left of that, and this gives you basically the probability to the left of Z. Z less than Z. We also call it area at Z. Area at Z means area to the left of Z. Okay, so that is basically given in your table. So how we can answer the questions? Of course, I will look for mu and sigma and then look at the tables to answer the question. For example, here, given a normal distribution with mean and sigma. See, so question number 15. Assignment 4. Mu is given 30, sigma is given 6. So, and X has a normal distribution. This should also be given to you with mu and sigma. So let's say if this is given or not. Given a normal distribution, see. So I will call, let X be the normal distribution. Let X has the normal distribution with mu and sigma, where mu sigma are that. Then I will define Z. Z is X minus mu by sigma. So means X minus 30 by 6. This is standard normal variable. Standard normal variable is basically having a normal distribution with mean 0. That means your Z also has a normal distribution with so now what are the questions? Question is, find the normal curve area to the left, to the right of 17. So they said, what is the probability of X to the right of 17? It's a normal curve area to the right of 17, basically. So that is, I cannot find because, first of all, just change it to Z. Change X to Z. So 17 in Z will become, see, my X is 17. So it will become 17 minus 30 by 6, right? Basically, this X is this one, right? So I will put this 17 minus 30 by 6, whatever X is. So it means this becomes probability of Z greater than 17 minus 13 is 30. 30 by 6 is 2 point something. 2.166666. But I will write 2.17 up to 2 digits. But this area cannot be found because if you make this figure 2.17 minus 2.17, right? Negative 17 minus 30. So that is somewhere here. Minus 2.17 because this is 0. So they are asking me this probability. But if I look at the table, table gives me the probability to the left, right? So if I look at the table, table will tell me Z less than minus 2.17. So it means I can subtract it from 1. You remember? When we go to the opposite side, we subtract it from 1. Okay, so this is the area to the left. Area to the left. What they are asking me, this one area to the right. This is area to the right. So I cannot find area to the right, but I can find area to the left, but then I will subtract it from 1 because the total area under the curve is 1. Now I will look at minus 2.17 in the table. So I hope I have table here. Standard normal table. So see here, this is shaded region, area to the left. So minus 2.17. So minus 2.1 is this one, and 7 is this. So 0.0150 minus 2.17, right? Minus 2.17, 0.0150, 0.0150. So how I saw that? I saw minus 2.1 on the left and 0.07 on the top. So if you go down here, go right here, this is 0.0150. All right. So if you subtract it from 0, I think it's 0.850. So 0.850 will be your answer to the right. So left comes directly from the table. Right will come from 1 minus left, right? And if they ask me between two values, let's say here, if they ask me between 32 and 41, so I will subtract the right minus the left between 32 and 41. So I will first convert these two numbers to z. See, x becomes z, 41 minus 30 by 6 and 32 minus 30 by 6. So first of all, first step is that convert this interval to z interval. So 32 minus 30 is 2 divided by 6 is 0.33. And 41 minus 30 is 11. Divided by 6 is 1.8333. So I will write 1.83. So now you see, they are asking you the area between. 1.83 is on the right here, and 0.33 is also on the right, 0.3. So they are asking you the area between them, right? But if I look at the area at 1.83, it will give me less than 83. This is the big area. But then if I look at 0.33, they will give me less than 0.33, this area. So if I subtract this smaller one from the bigger one, I will get this remaining portion, which is between them. So you can subtract the right minus the left. Okay. Both are basically left areas. But in short, you can write this as well. Probability area at the point which is on the right, area at the point which is on the left. So this will be your answer. So now if you look at the table, 1.83, did I close it? So 1.83 go down, this is 1.83, see, 1.83, see 1.8 and 0.03, right? So 0.9664 and 0.33. So 0.33 is, if I go down, no, up, this is 0.33, 0.33, right? 6293. And now you can subtract to get the answer. So normal distribution is also very easy. You just have to be careful in reading the question. Read the question carefully, what they are asking. Okay. Sometimes they ask us the opposite. Like, for example, here, what is the value of x that has 18% area to the left. So it means this is the opposite reverse use of table. Instead of asking you, see here, they give you X and ask you the probability. Here they ask you the probability. They said, what is X that gives me 80% area, 0.80 to the left of X. So basically they are asking me this. What is this X so that the area on the left is 80%. Area on the left is 80%, right? Find the value of X that has 80% area to the left. So first of all, you know that X minus mu by sigma is Z. So my X becomes mu plus sigma Z. You can multiply sigma here and add mu. So mu plus sigma Z. This is what I have. So it means I need Z first. First, I need Z. Right? So I will find Z that gives me 80% area below it. I will look for this Z. What is Z which gives me this one? So I will look at the table where the probability is given now. So if you go to the table, you will look for 0.80 area now. So area 0.80, let's say 0.7, 0.7, 0.77780, this one. So this is the closest, right? Closest to 0.8. So this now read Z. Now read Z. Area is given. So that is 0.8 and this is 0.4. So 0.4 is your Z that gives you 80% area to the left. So this gives you Z is equal to 0.84. Because from table, we know that area at 0.84 is 0.7995, which is approximately 8, so I can accept it. So that's where I got Z, and now I can just put this Z here, right? I will put this Z here to get X. So therefore, my X, therefore my X value is mu plus 6Z. Z is 0.84. So that will give me my X value. This is X value which has 80% area to the left. So I can multiply 6 with 0.84 and plus 30. So it's 35.05. So you can say 30. 35.04. So it's approximately 35. So this is the value of X, 35. That will give me almost 80% area to the left. All right. If they say find the value of X that has given area, let's say 60% area, I'm just to the right. Instead of giving you to the left, they said give me X which has 60% area to the right of it. So now I will not look 60 in the table because table only considers the left area. So if the right area is 0.6, then area to the left is 0.4. So I will not write this. I will instead of that write X less than X equal to 0.40. So I will look for Z that gives me 40% area to the left. Okay, so be careful. If they ask you find the value of X such that there is 60% area to the right of X, right? So then you will not consider 60% area. You will consider 40% area, which is to the left, and look for 40 in the table. So from here, your Z will come from the table. So table means 40. So that for smaller values go up. 0.8, 0.7, 0.6, 0.5. So it means I still go up. 0.4 is somewhere here. So 0.4 is closest is this one, right? So that is minus 0.201234.5, minus 0.25. So this value gives you z minus 0.25. So this gives you minus 0.25. So I will put this in x. So my x is 30 plus sigma mu plus sigma z. Z is minus 0.25. So now you will get this one. So this is the x that gives you 60% area to the right. Basically, this is the x that gives you 40% area to the left, but it is the same thing. Okay, 40% area to the left or 60 to the right is the same thing. So read the questions carefully. Don't rush towards the solution. Read it carefully. First, understand what the question is and then try to answer. All right, guys. So I think I revised everything that will be included in the exam. And of course, very similar to these questions will be there. So if you can do these exercise problems, you should not be worried about anything. Things will be very, very close to this one. If you have any questions, you can ask me. If this is good enough, then I think we can stop here and you just go through the questions, the remaining questions that I did not consider. Just try to do them at home. At least try 1, 2 questions from each topic, right? I gave you 3, 4, 5 questions from binomial, 3, 4 from Poisson. Normal has also 4, 5 problems. So at least try a couple of them in each topic so that you get the concepts, so that it's easy to attempt, during the exam. All right, guys. So I'm stopping the recording here. But if you